Hello students, we're going to be reviewing the practice for test 5 worksheet, and for problem number 1 we want to find a side of this triangle, side C, to the nearest tenth. Remember, sides are always denoted by lowercase letters, angles, capital letters. So here we first look to use SOHCAHTOA. SOHCAHTOA can only be used if you have a 90-degree angle, and here it doesn't look like there's a 90-degree angle, but sometimes there could be one and you don't know it. Here they give you two angles. They give you 77 degrees and 23 degrees. And I can go about finding angle B by adding up those two that are given to me and then subtracting it from 180. So it looks like here angle B, capital B, is going to be 80 degrees. So there's no SOHCAHTOA because there's no 90-degree angle. So next we try to use the law of sines. To use the law of sines, you need to have one matching set of side angles and one half matching set. So in this case here, the half matching set is what you're solving for. So here, I'm trying to solve for little c, so I'm going to first look to see if I have a half matching set of the c's, and it looks like I do. Here I have angle C is 23 degrees, and I'm trying to find side C, so the C's are my half matching set. Now in order to use the law of sines, I need one matching set of side angles, and here I have that with the A's. Here I have angle A, and here I have side A. So I have enough information to use the law of sines. The law of sines is always a fraction equal to a fraction, and my advice is to always put what you're solving for in the upper left-hand corner. So here, since I'm solving for little c, I'm going to write little c over the sine of big C. That equals, now my matching set were my A's, so little a over the sine of angle A. Remember, the sine is always attached to the angle that you're using. So here I'm now going to substitute into this law of sines. So I'm going to have little c, that's what I'm solving for, so maybe I'll call that x, over the sine of angle C, so that's the sine of 23 degrees. That equals little a, so the side opposite angle A, 15, over the sine of angle A, in this case the sine of 77. And when we use the law of sines, we always cross multiply. So here we're going to have x times the sine of 77, and that equals 15 times the sine of 23 degrees. And here now, to solve for x, I'm going to divide both sides by the sine of 77. So here I'm finding side C, and I'm going to do that by doing on my calculator 15 times the sine of 23 over the sine of 77. So here our answer is going to be 6.0. You always find sides to the nearest tenth. You always find angles to the nearest minute. So in this case here, 6.0. Question number 2. Here we're trying to find angle B, capital B, to the nearest degree. Again, I look to see if I can use SOHCAHTOA, but I have only one angle given to me, so there's no way of finding the other two angles, and I don't see 90 degrees, so I can't use SOHCAHTOA. So next I'm going to try to use the law of sines. The law of sines means we need one matching set, and I need one half matching set, and the half matching set is what I'm solving for. So here I'm solving for angle B, so I'm solving for this angle. Do I have the half matching set? I think I do, because here I have side B. So my B's are going to be my half matching set. And now to use the law of sines, I need one entire matching set. And it looks like here the matching set are going to be my C's, because I have angle C and I have side C. So to use the law of sines, we're going to have a fraction over a fraction. And here, since we're trying to find angle B, I'm going to write angle B up top, and remember the sine is always attached to the angle. So here I have the sine of angle B over little b, that equals the sine of angle C over little c. So now I'm going to substitute in. Here I'm going to have the sine of angle B. Well, that's what I'm solving for, so maybe the sine of x over little b, which you're told is 22. That equals the sine of angle C, which they tell you is 48 degrees, divided by little c, which you're told is 63. So here I'm going to go about cross-multiplying to solve for x. So here I'm going to have 63 times the sine of x. That equals 22 times the sine of 48. And now to solve for x is attached to the sine, so I can't get rid of sine yet. So here I'm going to divide both sides by 63. So here I have the sine of x equals 22 times the sine of 48 over 63. And here, since I'm finding an angle, I have to remember to press the second button and then to DMS my answer. Anytime you're finding an angle, you always want to make sure you see this inverse symbol, so the inverse sign, and then 22 times, this is the regular sign, so you're going to be doing second sign first, but then here you're going to be doing the regular sign, and here to the nearest minute, because we always find sides to the nearest tenth, we always find angles to the nearest minute. Here we look to see if it's 30 or more. If it is, we would round up. Well, here it's not 30, it's 27, so here my answer is going to stay the same, so it's going to be 15 degrees, 2 minutes. Problem 3, I have to find little d. Again, I look for a right angle. I don't see any. I have a 97 degree angle and a 42 degree angle. So if I add them up and subtract that from 180, it looks like the missing angle, angle E, is 41 degrees. So I have no right angle, so I'm not using SOHCAHTOA. So next I'm going to try to find and use the law of sines. Here, the half matching set, that's what you're solving for. So the half matching set looks like are going to be the D's, because I'm solving for little d. And here my matching set appears to be my F's. So my matching set are my F's. So I have enough information to use the law of sines. I'm solving for little d, so I'm going to go little d over the sine of angle d. And now for my F's, I'm going to have little f over the sine of angle f. So I'm going to have little d, that's what I'm solving for, over the sine of angle d, the sine of 42. That equals little f over the sine of angle f. So I'm going to set up x over the sine of 42. That equals 12 over the sine of 97. So I'm going to cross multiply. I have x times the sine of 97. That equals 12 times the sine of 42. And now to solve for x, I'm going to divide both sides by the sine of 97. And here, since I'm finding a side, I'm going to go to the nearest tenth. So basically, I'm just going to type in exactly what I see and round to the nearest tenth. So here my answer is going to be 8.1. 8.1. For number 5, here I'm finding angle A. So I look to use SOHCAHTOA, but there's no 90 degree angle. I only have a 123 degree angle. So next I'll try to use the law of sines. The sines, I need a half matching set, which is what you're solving for. So it looks like here my half matching set are going to be angle and side A. And my half matching set, okay, so that's my half matching set, the A's. And here my matching set looks like is going to be the B's, because I have angle B and I have side B. So here I have enough information to use the law of sines. I'm going to set up my fractions. Always put what you're solving for in the upper left-hand corner. So here I'm trying to find big A, or angle A. Remember, the sine is always attached to the angle. So I have the sine of A over little a. That equals now my matching set, the sine of B over little b. So here I'm going to have the sine of angle A, which is what I'm solving for. So the sine of x over little a, which is 19. That equals the sine of angle B, so the sine of 123, over little b, which you're told is 43. So that's the equation that I'm going to use to solve for angle A. So I'm going to cross multiply. I'm going to have 43 times the sine of x. That equals 19 times the sine of 123. So I'm going to divide both sides by 43 since I'm trying to find the angle. And remember, the angle is always attached to the sine, so you can't get it by itself. So here I'm going to have the sine of x equals 19 times the sine of 123 over 43. And remember, since you're finding an angle, the two things you have to remember, you have to press the second button first, and then you have to DMS your answer. So I'm going to look at my seconds, which are 3. So since that's under 30, it's going to stay the same. So here my answer is 21 degrees, 45 minutes. We always find sides to the nearest tenth. We always find angles to the nearest minute. The next two problems have us solving a triangle. Remember, to solve a triangle, it means you need to know what all three angles are, and you need to know what all three sides are by the end of the problem. So here you're told angle C is 90 degrees. You're told angle B is 62 degrees and 30 minutes. And here you're told, well, here's angle B. So here they're telling you side B, or little b, is 22.6. So here the three missing parts are angle A, side A, and side C. When you have two of the three angles, the first thing I suggest you do is to add up the two that you have and subtract from 180 to find the third angle. So here I added up my 90 degrees and my 62 degrees 30 minutes. I did 180 minus that previous answer, which is second in the negative button on your calculator. So here it looks like angle A, big A, is 27 degrees and 30 minutes. So I'm going to fill that in on my information. And now I'm going to go about finding my two sides. I'll start off with side A, which is opposite angle A. So now I'm going to use trigonometry to figure out what little a is. My angle in the problem is never going to be the 90 degrees, so I'm not going to use 90 degrees. And we have these two other angles from which to choose, and I suggest you always choose the angle that's given to you, because you know that's correct, because it's given to you. You could have made an error finding the other angle. So I'm going to go, my angle is 62 degrees 30 minutes. I'm going to label my triangle, so my right angle, opposite is the hypotenuse. Here is my angle, so opposite is 22.6. And I'm trying to find x, which, since this is my angle, x is going to be the adjacent side. So I label my information. I'm using SOHCAHTOA because there's a right angle. Here I have the O and the A of SOHCAHTOA, so that's going to be the tangent. The tangent of an angle equals opposite over adjacent. So the tangent of the angle, the tangent of 62:30, that equals the opposite, which is 22.6, over the adjacent, which is x. So here I'm going to try to solve this by cross-multiplying. But since my x is in the denominator, I'm going to use that switcheroo rule. I'm going to bring the x to the top. So here I'm going to have x, and then that equals the 22.6, and now I'm going to bring the tangent to the bottom. So the tangent of 62 degrees, 30 minutes. So since I'm finding a side, I'm finding side A. I'm going to round to the nearest tenth. I'm just going to type in exactly what I see. So I'm going to type in 22.6 over the tangent of 62:30. So here it looks like little a is going to be 11.8. So now I'm almost done. I'm trying to solve the triangle. I'm trying to find all the missing parts. So here my last part is to find little c. And just like what we did in the beginning, when you have two of the three angles, you always add them up and subtract from 180. When you have two of the three sides, so here we have side A and side B, when you have two of the three sides, I suggest you use the Pythagorean theorem to find the missing side, since this is a right triangle. So here's what I have. I have my diagram. I have, this is 22.6. I just solved for x. That was 11.8. I'm trying to find my missing side. Here I'm using the Pythagorean theorem, and the most important letter in the Pythagorean theorem is letter C, the hypotenuse. So in this case here, the hypotenuse is going to be x. So I'm going to do 11.8 squared plus 22.6 squared equals x squared. And I'm going to simplify this left-hand side on my calculator. So here I'm going to have 650 equals x squared. And now to solve for x, I'm going to take the square root of both sides. So here x is going to be equal to the square root of 650. I'm going to do that on my calculator. And remember, we're finding a side, so always round to the nearest tenth. So the square root of 650 to the nearest tenth is 25.5. So now I'm done. I solved the triangle. I found all the missing angles, all the missing sides. So this side is 25.5, and it kind of makes sense because the hypotenuse is always the longest side of the right triangle, and it turned out to be 25.5. This is 22.6. This is 11.8. So now I'm done solving the triangle. The next problem is another solving a triangle question. So remember, the goal is to have all three angles and all three sides. And they're always going to tell you 3 of the 6 things you need to find. Here they're telling you angle C is 90 degrees. Here they're telling you 2 of the sides. So angle B, opposite that is side B. So here they're telling you side B is 4.5. And then angle A, opposite that is side A. So here they're telling you little a is 5.5. So they're telling you 2 of the 3 sides. We have to find 2 angles and the 1 remaining side. Since they give you 2 of the 3 sides, to find the missing side, I'm going to use the Pythagorean theorem. The most important letter in the Pythagorean theorem is the hypotenuse, or letter C. And in this case here, that's what you're trying to solve for. So that's going to be my x. My other 2 sides really don't matter, 5.5 and 4.5, or if you switch them, 4.5 and 5.5. So here we're going to solve for x by first doing this left-hand side on your calculator. So here we're going to have 50.5 equals x squared. And then the way you solve for x is you take the square root of both sides. So here the missing side c is going to be the square root of 50.5, or 7.1. So here side C is 7.1. That's the hypotenuse. Always good to check and make sure it's the longest of the 3 sides. And here it is, because it's bigger than 4.5 and 5.5. So now I have to go about finding the other 2 angles. Doesn't really matter which angle you try to solve for first. I'm going to choose angle A. I'm going to redraw my diagram to help you out. Now to find angle A, my angle that I'm using is going to be x, because that's going to be angle A. Now I have all 3 sides, but remember I just went about finding side C, and I could have made a mistake. So I'm not going to use that side C. Instead, I'm going to use the other 2 sides that were given to me in the problem. Here my angle is x, so my 5.5 is opposite the x. And since the 7.1 is the hypotenuse, the 4.5 is the adjacent. So here 5.5 is opposite, 4.5 is adjacent. So here I have the O and the A of SOHCAHTOA, so I'm going to be using the tangent. I know the tangent of the angle equals the opposite over the adjacent, so the tangent of x, that equals the opposite, 5.5, over the adjacent, 4.5. And here, since I'm finding an angle, the two things you have to remember is to press the second button first, and then to DMS your answer. So it looks like angle A is going to turn out to be 50 degrees, and then I look at my seconds. Here my seconds are bigger than 30, so that's going to kick that up by 1. So here angle A is going to be 50 degrees, 43 minutes. Now I'm almost done. The last step is to find angle B, and now since I have two of the angles, I'm going to add them up and subtract from 180 degrees to find the missing angle. So here I added up the 90 degrees and the 50 degrees, 43 minutes. I did 180 minus that previous answer, and then I DMS'd my answer, which means here my last angle, my last part of the puzzle to solve the triangle, angle B, is 39 degrees and 17 minutes.